Suraj, tell me, which part you want me to discuss? Suraj? हेलो.
यस यस सर यस सर
बोलो कौन सा पार्ट सैलो फाउंडेशन का डिस्कस करेंगे, कौन सा चीज?
सर वो जो वाटर लेवल चल लेते हैं ना कि
वाटर टेबल,
जैसे
वाटर टेबल.
ये सर जब पानी ऊपर आ जाता है तो डी
हाँ हाँ
वन जीरो डी
हाँ
वन जीरो
हाँ
या
हाँ, ठीक है
सर
ठीक है,
उस
ओके
पे
ओके. वाटर टेबल करेक्शन, वाटर टेबल करेक्शन. ओके, let me discuss it. No problem. See, that is very important part, okay? Because in GATE exam also you will get many questions, relevant questions from that. It's very simple actually. Let me show that part again. See, can you see this? Can you see the screen?
यस सर
So you see, uh, water table correction when we are talking about in case of shallow foundation, that is basically the effect of water table on bearing capacity of shallow foundation. Okay, so it's a very important concept. Earlier also we have discussed it. It's very simple to understand. See, don't worry much about it. See, very simple to understand. Only thing what you'll have to do, you'll have to remember this diagram, or you'll have to follow this diagram properly. Then only it will be very simple to understand. See, in case of uh, basically a C5 kind of soil. Okay, so C5 soil means when the soil is basically a mix of cohesive and non-cohesive, non-cohesive nature soil. That means a mix of clay and mix of sand. Okay, so in such case, when the soil is a C5 soil, so for such condition, what actually you have to do, you will have to calculate the effective stress parameter, that is the phi dash. Phi dash means the effective angle of internal friction of soil, and along with that you need to change the unit weight of soil. Okay, so this is actually will be taken into consideration while you will be putting the values in case of the bearing capacity equation. Now you see Terzaghi's bearing capacity equation. If you observe, what is Terzaghi's bearing capacity equation? Terzaghi's bearing capacity equation, you see, it is nothing but ultimate bearing capacity. You see, it is nothing but CNC, then QNQ, and then 0.5 gamma BN gamma. So what is Q? Q is nothing but gamma D NQ. Okay, gamma D. So gamma D is nothing but the effective unit weight of effective stress of the soil. Okay, and 0.5 gamma B N gamma. Now if there is the presence of water table, if there is a presence of water table within the influence zone of the shallow foundation, this is very important, within the influence zone of the shallow foundation. And to understand the influence zone of the shallow foundation, if you remember, when I have discussed about Terzaghi's bearing capacity equation, at that time we have spoken about three zones, if you remember, right? So there is a triangular separate zone, and then there is zone 1, zone 2, and zone 3. So if you remember that zone 1, which is basically a triangle separate zone, or the zone which we were calling it the zone of elastic equilibrium, in that zone if you see, the height of the triangle from the base of the footing is nothing but b. So that is actually Terzaghi's formulation. From the Terzaghi's formulation it is coming that the influence zone of a shallow foundation, that means the amount of soil which will be participating in the shear resistance capacity of your shallow foundation, the depth of that soil will be equal to B. That is, B means the breadth of the footing. So from the base of the footing, the influence zone, that means influence zone means the amount of soil which will be participating in the shear resistance, that will be equal to B. Okay, what is this B? This B is nothing but the breadth of the footing. So that means you understand now, if the depth of the footing is df, that means depth of the footing from the ground level to the base of the footing, that is the depth of the footing. Now from the base of the footing, from this point, from the base of the footing, the limit of influence will be up to a depth of B. And what is this B? B is nothing but the width of the footing. Okay. Now, when this limit of influence is defined, if your water table is away from the limit of influence, that means if your water table is below the limit of influence, that means if you see, if your water table is somewhere here, or if your water table is somewhere here, or your water table is somewhere here, that means if it is at a depth below df plus b from the ground level, or you can say if the water table is at a depth below b from the base of the footing, at a depth below, at a depth b or below that depth, if your water table is present, then you see there is no influence of water table on the bearing capacity, because you see the bearing capacity, whatever the equation you are getting, that is being formulated with the assumption that the influence zone, or you can say the amount of soil which will be participating in the shear resistance, that will be up to the depth B from the bottom of the footing, where B is nothing but the width of the footing. So if the water table is beyond the limit of influence, so if it is just reaching at the limit of influence or it is below the limit of influence, then there is no effect of water table on the bearing capacity of soil. Okay. Now next is, suppose during the rainy season or suppose during any season, if the presence of water table is above this limit of influence. So limit of influence is here. Now let's say the water table is rising up, and let's say somewhere the water table is present over here. Okay. Now if the water table, the presence of water table is over here, then you see there are two factors in this bearing capacity equation. One is one portion of the equation you see which is involved with gamma d. So this Q and Q, this gamma d, Q means what? Gamma d. So this factor, this Q and Q factor will be affected by water table if the water table is up to the depth of d, up to the depth d of the footing. But if the water table is beyond the depth d, you see, if it is water table is beyond the depth d, that means in this case where you see water table hasn't reached this depth d, it is little bit down the depth d. In that case, you see in the bearing capacity equation there is another one factor, that is 0.5 gamma b. See, this term is involved with b. So this b term will be getting impacted with the water table, and thus this water table, this factor, this portion of the bearing capacity equation will be required to be multiplied with a factor which we are mentioning here Rw2, and this Rw2 is nothing but the water table correction factor. Now what is this Rw2 actually doing? See, this Rw2 is actually reducing this value of gamma. That is what you should be very clear about. Suppose you do not use this RW2 factor, then what you will have to do, instead of this gamma, which is being considered as the gamma bulk in case of, which is actually the gamma bulk in case of, just a minute, okay. So you see this when we are talking about this RW2 factor, as we are saying, it will be impacted with this B. So it will impact this B. So when the water table is within this depth B below the bottom of the footing, then only you will be applying this RW2 factor. Okay. So what you are doing with this RW2, very clearly understand this. This is very important. See, with this RW2, actually you are changing the value of this gamma. Actually you are impacting this gamma. So you see, when Terzaghi has given his bearing capacity equation, in that bearing capacity equation he hasn't considered anything about water table, right? So in that equation, if you observe, the gamma, the unit weight of soil, is being considered as gamma bulk. So bulk unit weight of soil has been considered in that equation. Now instead of the gamma bulk, if you want to use some other unit weight of soil, because you see, when the water table is going up, then the unit weight of soil will be getting changed. The portion of the soil which will be completely under the water table, that will be actually in submerged state. The other portion of the soil may be under saturated state, or it may be under bulk state. So it's very difficult to determine from the presence of the water table what will be the exact unit weight of the soil. So to substantiate that effort of determining the unit weight of the soil, exact unit weight of the soil rather, we can use an interpolation function, and this interpolation function is actually called as water table correction factor, and that is in this case is given as RW2. Now here you see, the important thing you should notice here, that this RW2 is given as 0.5 into 1 plus dW dash. This is very important. So you see, dW dash means what? dW dash is nothing but the depth of the water table. So this is your this is the water table is now present over here. So the water table, the depth of the water table from the base of the footing is dW dash, and the width of the footing is B. So when the width of the footing is B, the influence zone will be extending from the base of the footing to a depth B. So you see, the interpolation function or the water table correction factor RW2 in this case will be given as 0.5 into 1 plus dW dash by B. So you should be very careful about this dW dash value. See, dW dash, how you are calculating, how you are finding out this dW dash? This dW dash is nothing but the depth of the water table. Very, very carefully observe. So from the base of the footing to the depth of the water table should be considered as dW dash. Now you see, from this interpolation function, what actually you are getting, you see, when you observe this dW dash is equal to B, that means the water table or dW dash is greater than B. So if dW dash is greater than B, then what will happen? There is no influence of water table on the bearing capacity. Thus the RW2 factor will be always equal to 1. Now you see, when the water table has just reached the limit of influence, when it will just reach this limit of influence, at that time what will happen? At that time you observe this dw dash will be taken from the base of the footing up to this. That means the value of dw dash will become equal to b. So what will be the value of RW2? RW2 will be 1 plus b by b. So b by b is going to give you 1. So 1 plus 1 is equal to 2. 0.5 multiplied by 2, half of 2 is going to be equal to 1. Right? So that way your RW2, that is the water table correction factor, when the water table is exactly just reaching the limit of influence, at that time also it will be equal to 1. Is it clear? Now the next point you see, next point is very important. You see, so when you see, when this RW2 is equal to 1, when this RW2 is equal to 1, then you see, if we put the value of RW2 is equal to 1, then you see, in case of Terzaghi's bearing capacity equation, this gamma is taken as gamma bulk. So you see, the water table is exactly not affecting the unit weight of soil at all. Okay. Now you see, when the water table is rising up, and suppose it has reached somewhere here, the presence of water table is now at a depth dw dash from the base of the footing. At that time you see, this value of RW2 will be given as 0.5 into 1 plus dw dash by b, and you see this dw dash by b thus will be lesser than some value of 1. So 1 plus lesser than some value of 1 and 0.5 it is multiplied. So your RW2 is going to have a value which will be having lesser than 1. And when, what actually it is doing? So when RW2 value is getting lesser than 1, then you see this gamma will be automatically getting reduced. See, your B is not getting reduced, your N gamma is not getting reduced, your gamma is getting reduced because of this RW2 factor. Now you see why you require this water table correction. You see, the gamma you need to be using the exact value of gamma. That is, instead of gamma bulk, you may have to use the gamma saturated for this portion of the, gamma submerged for this portion of the soil which is below the water table. That soil is basically submerged soil. So you must use this gamma instead of gamma for this up to this depth. You should be using gamma submerged, and from here to here you should be using, let's say, gamma saturated. So to substantiate that or to overcome that in a easier way, what you are doing, you are just using an interpolation function, that is RW2. Now see, the beauty of this interpolation function is, this is very simple interpolation function actually. So you see, when this water table, this one will gradually rise up, and let's say it reaches the base of the footing. When it just reaches this base of the footing, at that time what will happen? When it will reach the base of this footing, it will be just affecting the way it will be affecting this RW2 factor. You see, this dw dash will become equal to 0, and thus your RW2 factor will become 0.5 multiplied by 1, and that will become equal to 0.5. Okay. So that way what is happening, actually your value of your just a minute. So you see, just when you see this RW2 value is going to be equal to 0.5, what does it mean? Actually you see it means that this value of gamma, that means whatever is gamma value, that is gamma bulk, is now having value of half of that. That means 50% of that gamma value. That means you see your gamma submerged is generally equal to half of your gamma saturated, or in some cases, in nearest cases, it may be equal to half of the gamma bulk. So actually you see, when this water table is reaching this base of the footing, what is happening? It is actually reducing this value of gamma to half of its original value, that is gamma bulk or gamma saturated. And basically, instead of this RW2 factor, when this water table will reach this base of the footing, if you use the value of gamma as gamma submerged, then also your calculation will be perfect. So basically you try to understand this RW1 and RW2 factors are nothing but the interpolation functions which automatically takes care about the reduction of unit weight of soil because of the increase in the because of the presence of water table. Okay, now let us go to the next part. So next part, you see, now you see water table, let's say it goes up. So when up to this, when the water table is present, then you see this portion of the equation will be getting affected. But beyond that, so when the water table will rise more above the base of the footing, then you see the influence in this bearing capacity equation will be taken care by this QNQ term, that means this gamma D term. What is Q? Q is nothing but your gamma into D. So this gamma D term now will be, so this Q, which is nothing but gamma D, so this gamma will be now getting impacted if your water table rises above the base of the footing. Is it clear? So when the water table rises above the base of the footing, we are introducing another one interpolation function, which is RW1. And this gamma will be now getting reduced by this RW1, which is given as RW1 is equal to 0.5. And you please observe it very carefully. You see, here we have taken it is dW dash. On the other hand, up to this depth of the footing, we are taking in that interpolation function the presence of water table, that is dW, is from the ground level. It is from the ground level. So dW is the value of the depth of the water table from the ground level. Okay, so this dW divided by this dF, that is depth of the footing. Now you see the beauty of this interpolation function. Again, you can observe very carefully. If you observe, see, when the water table has just reached this base of the footing, what we have seen for this term, we have seen for the B term, the attached B term in this bearing capacity equation, we have seen this RW2 value is becoming 0.5, isn't it? So that means the gamma is being reduced to half of it. That means we'll have to use the gamma submerged value for this portion when the water table has reached this. Now you see, when this water table has reached this base of the footing, then you see this dW, if I say this water table is now present over here, so what will be the value of this dW? This value of this dW now will be equal to dF, and thus if we put dW in place of dW, if we put dF, then dF by dF, that is going to give you 1. So 1 plus 1 will be equal to 2. 2 multiplied by 0.5, that will be going to give you 1. So you see, when the water table has just reached the base of the footing, you see your RW21 value will be equal to sorry, Rw1 value will be equal to 1. That means what? That means your gamma d NQ term remains unaltered. That means what? That means your gamma is remaining unchanged. That means whatever gamma you are having for this portion of the soil, that means you can directly use the value of the gamma bulk or whatever gamma you have calculated from your testing of that soil. That gamma you can directly use in the equation. But if the water table rises further up, that means it increases its level from the base of the footing and it is moving towards the ground level. So if it moves towards the ground level at an in between position somewhere over here, let's say, so let's say the value of this dW, then in that case what will happen when the water table reaches somewhere at this position, then you see this dW will be lesser than this dF. So when this dW becomes lesser than this dF, when this dW becomes lesser than this dF, then you see this term will be lesser than 1. So 1 plus a lesser than 1 term will be lesser than 2, and then if you multiply it with 0.5, then you see this value is going to be lesser than 1. Okay, so that means what is happening? That means when the water table has risen up, the level beyond the base of the footing, at that time you see your gamma d NQ term will be also getting impacted. That means you need to reduce the value of gamma by multiplying with the factor Rw1. And what is that Rw1? Rw1 is nothing but for this much portion of the soil, as we have explained it earlier also, for the this much portion of the soil, your soil is actually submerged, and beyond this up to this dW depth the soil is not submerged, right? So when the soil is submerged, then it is actually half of the unit weight of the saturated or bulk unit weight, and beyond that you will have to use the saturated unit weight of soil. So instead of using the actual unit weight of soil, what you are doing by using this interpolation function, which is nothing but this Rw1 and Rw2, actually you are reducing the unit weight of soil, and you are nearly going to an approximation of the unit reduction of the unit weight of soil. That is what is actually Rw1 and Rw2 doing. Okay, now let's say if the water table further increases or it goes up and it reaches the ground level. So when it will reach the ground level, what will be the value of your dW? Your value of dW will in that case will become equal to 0. So 1 plus 0 by dF, so 0.5 plus 0.5 multiplied by 1, that means it will be equal to 0.5, and you see that is what actually will happen. So if you consider when this water table is reaching this ground level, that means what will happen? The complete portion of the soil up to the depth of the footing will be under submerged condition, and the submerged unit weight of soil is equal to half of the saturated unit weight of soil or a bulk unit weight of soil. So this Rw1, when it takes a value of 0.5, actually what is happening? This Q term, that means Q term is having basically the gamma d, so gamma is being reduced to half, which is nothing but, you see, approximately equal to the submerged unit weight of soil. Okay, so this is what actually your water table correction factor, and how you should include the water table correction in case of shallow foundation for calculation of the bearing capacity. So is it clear?
Yes, sir.
So any doubt? Any doubt? So see, it's very simple. Only thing you should remember this diagram. This diagram is very important. If you can draw this diagram, see, in many cases, if you see the competitive exam papers, if you look at the GATE examination paper or engineering services exam paper, only the confusion is being created with the location of the water table. Location of the water table means, what is location of the water table? Location of water table means this one, this triangular thing. Okay, so sometimes you will see it will be said in the question that water table is at a depth below the ground level. Sometimes you will see it will be said that water table is above the base of the footing. So from that you should be exactly inferring what will be the value of your dW and what will be the value of your dW dash. Are you getting? So when it will be said that water table is at a depth of let's say I'll take one example to explain you in more clear way. Let's say in this problem only, in this diagram only, let's say this df, this depth of the footing, let's say 1 meter. Okay, and let's say this breadth of the footing, let's say it is 1.5 meter. Okay, so if I tell you, if the water table is, so how much is the depth of the footing? I said depth of the footing is 1 meter and this breadth of the footing is equal to 1.5 meter. So how much will be the influence zone? Influence zone will be below this base of the footing up to a depth of 1.5 meter. So B is equal to 1.5 meter. So now suppose the question is being asked in this way. The water table is present at a depth 3.5 meter below the ground level. What does it mean? So 3.5 meter below the ground level means ground level is here. So 3.5 meter below means, see, this is 1 meter, from here to here it is 1.5 meter. So total from here to here it is 2.5 meter. So water table, when it is said it is below 3.5 meter depth below the ground level, that means it is, water table is somewhere present over here. That means it is beyond the limit of influence. So when the water table is beyond the limit of influence, you need not to bother about its effect on bearing capacity, because your Rw1 and Rw2 factors will be automatically become equal to 1 in such case. Okay. Now next is, suppose you are said that water table is at a depth of 2 meter below the ground level. The question is, water table is at a depth of 2 meter below the ground level. So where is the water table in that case? See, water table is at a depth of 2 meter below the ground level. That means from here to here it is 1 meter, and from here to here it is 1 meter. So 2 meter below the ground level means it will cross the depth of the footing and it will come somewhere here, right? It will come somewhere here. Now you should be very, very careful in understanding this point. See, the problem says water table is at a depth 2 meter below the ground level. So that means from here to here the distance is being said 2 meter. So while calculating the value of Rw2, you should be very careful about finding this value of dW dash. You should not put the value of dW dash equal to 2 meter. Instead, what you will have to put? From here to here it is 2 meter, from here to here it is 1 meter. So dW dash will be equal to 2 minus 1 is equal to 1 meter. So here the dW dash value needs to be put as 1 and this B needs to be put as 1.5. So you see 1 by 1.5 in that case will be becoming equal to lesser than 1. So 1 plus some value lesser than 1 is going to give you 1 point something, which is when multiplied with 0.5 you are going to get a value which will be obviously lesser than 1, and that's what it will impact this value of gamma, and this gamma will be reduced by that term. Okay, and in this case you should observe very carefully when it is being said water table is at a 2-meter depth from the ground level. You see, water table 2-meter at a depth from the ground level means it is somewhere here. So the above portion from the base of the footing, that means up to the depth of the footing, this region will be remaining unimpacted because of the water table correction. So you should automatically use the value of Rw1 is equal to 1, or rather you should use the gamma d nq in that term. You should use the value of gamma as gamma bulk. Okay, now the same problem may be tweaked in this way, or it can be very easily said in this way that the water table is present at a depth 1 meter from the base of the footing. So that is another one thing. Okay, water table is at a depth 1 meter from the base of the footing. Okay, so if it is said that 1 meter from the base of the footing, then what will happen? 1 meter from the base of the footing and 2 meter from the ground level is exactly the same condition. 1 meter from the base of the footing, that means from here to here it is 1 meter. So what you are getting? You are getting directly dw dash in this case. You are directly getting dw dash in this case. However, if you are asked that, or if you are told in the question that the water table is at a depth 1 meter, 2 meter from the ground level, then you will have to calculate this value of dw dash carefully. This is what is the tweak in the problem you may get. Otherwise, it is very simple. Okay. So I think with this you should be if you practice problems, then I don't think you should be facing any problem. If you face problem while solving the problem, we can again take it up and we can again discuss 1 or 2 problems regarding this. Okay. So any other question, any other thing from shallow foundation? If you want to ask, then we have another 10 minutes, we can discuss. 5 minutes, in next 5 minutes we can discuss. So Suraj, is it clear?
Yes, sir.
Okay. So all others, if you have still any doubt, then you can ask. So do you have any more doubt from shallow foundation?
सर
सुमित बोलो.
IC IQ एंड I गामा फैक्टर एक बार और समझा दीजिए थोड़ा.
IC IQ I gamma. Okay.
Yes.
Okay. So let us go to this. See, in case of general shear failure or local shear failure, whatever you take, see Terzaghi's equation is being considered for what? Terzaghi has given his equation considering the footing as a strip footing, right? It is a strip footing. Okay. So what is a strip footing? Strip footing is a footing where the length of the footing, that means the dimension in the footing in the other direction is much more than the dimension is one direction on the horizontal plane. That means the length of the footing is much greater than the breadth of the footing. So considering that, Terzaghi has given his bearing capacity equation. So considering that equation, you have the Terzaghi's bearing capacity equation as CNC plus gamma dnq plus gamma bn gamma, right? Now, if you want to apply the same generic equation of Terzaghi in a general form to the footing which are rectangular in nature, which are circular, which are square. So in such case you need to introduce a factor into the equation which are called shape factor. So in that case you need to multiply each and every term. That means what you are actually doing, the dimensionless number of NC, NQ, N gamma, which are the bearing capacity factors, those factors you are multiplying with a factor which you can easily get from some formula which are experimentally proven. So for different shapes of footing you introduce one factor that is called SC, SQ, S gamma. So similar to that, suppose if you think about Terzaghi's bearing capacity equation, if you remember when you have discussed about Terzaghi's bearing capacity equation, you see the load which used to act on the footing is basically the vertical load. Okay. So when it is a vertical load, then you can you can use CNC SC plus gamma D NQ SQ plus 0.5 gamma B S gamma. There is no problem. But if the load is not acting on the footing, that means the load is not acting on the column, who is transferring the load from the column to the footing. So column is basically transferring the load from the superstructure to the footing. So suppose the load which is acting on the footing is not vertical, if it is inclined in some way. In some cases you see, suppose there is a column, on that column there is a vertical load acting, as well as from other direction there is a horizontal load also acting. So if you see the vertical load and horizontal load, both way the components when you will take, it will be some inclined one, right? So when you think that when you see that the load is inclined to the column or to the vertical axis of the column, in that case, to get the effect of bearing capacity of the foundation, you need to introduce a factor which is called inclination factor, and that is being considered also in our Indian Standard Code, that is IS 6403. So this inclination factor will take care about the inclined load which is acting on the foundation, and these factors are given as IC, IQ, I gamma. Only thing you need to remember that when we are talking about this inclination factor, the value of inclination factor, whatever is given, this IC, IQ and I gamma, you see the value of IC is given as equal to IQ, and that is given as 1 minus alpha by 90 degree. See, this alpha is very important term, and this alpha you should remember, this is the inclination of the load with the vertical axis of the column, not with the horizontal. So here also there may be some tricky questions coming where you will be given the inclination of the load with the horizontal. However, while applying the inclination factor or while applying the formula, what you will have to do, from the horizontal angle you must convert it to the inclination with the vertical axis, then only you put the value over here. Okay, and once you put the value over here, so if you see the alpha value is basically the inclination of the angle inclination of the load with the vertical axis of the column. Let's say with the horizontal axis, with the horizontal line, if the angle is given 60 degree, that means the inclination of the load with the vertical axis of the column will be 90 minus 60 is equal to 30 degree. Only this much tricky thing it may come. So inclination factor is basically a factor which is basically IC, IQ, I gamma. With these three terms you will get, these are nothing but the factors which will be used in Terzaghi's bearing capacity equation, or in the modified form of different bearing capacity equation, to take care about the inclined load which will be acting on a column. Is it clear? Okay.
Yes,
So,
sir.
okay. Okay. So I think today now we'll stop here. So today again we are having another one class. Okay. So at what is the time? 1:45. Okay. So today 1:45 we will discuss another one thing, just for half an hour maybe we will be taking. Okay. Let's say half an hour, 35 minutes, 40 minutes we will discuss. We will discuss about the consolidation part. If you have any doubt in consolidation, then we will discuss, and then we will get into a little bit new thing which will be again discussing after your Diwali vacation. Okay, after this Diwali we will be again taking it up, but I will just try to introduce it to the time rate of consolidation. We have till discussed up to the settlement from consolidation, but time rate of consolidation we haven't discussed. So I will just introduce you to that part in the next class. Okay. Okay. So let me take the attendance first, then you can leave. Okay, for your lunch. So let me refresh it. Okay. Okay, thank you. You can leave now. Okay.